Okay guys, we now look at a Vernier caliper and a micrometer screw gauge. So oftentimes we have a length less than 0.1 centimeters or 1 millimeter which we need to measure. So a ruler in that case or a tape measure, they are not suitable to measure such lengths. Then in that case we might choose to use a micrometer screw gauge, or a Vernier calipers. So let's look at a Vernier calipers and see how it measures small lengths. So here is a Vernier caliper. So a Vernier caliper has inside jaws. These are inside jaws. These are inside jaws. These are inside jaws. And these are outside jaws. These are outside jaws. We also have a depth bar. This is a depth bar for measuring the depth. Could be the depth of a beaker, measuring cylinder, or anything of that kind, right? Then here we have our main scale. This is the main scale. The main scale is just like the scale of a ruler. On top of a main scale, we also have a Vernier scale. So a Vernier scale is here. This is a Vernier scale. So I have enlarged the diagram here. So this is the main scale. This is the Vernier scale. The Vernier scale is from 0 to 10. From 0 to 10. So let's see how a Vernier caliper can be used to measure on different lengths. So here is our Vernier caliper. So in this case we are using the outside jaws to measure the external diameter here. We are also using the outside jaws to measure the diameter of a sphere. We are using here the internal or inside jaws rather to measure the what? The inside diameter of this is just a cup, right? So this is how we can use the Vernier caliper. So if we want to measure the depth of this cup, we will use this depth bar. So let's see how we take readings from a Vernier caliper. So here is a ruler. I've placed this side to side with the scale of a Vernier caliper. This is a ruler. So with a ruler, when measuring length for this object particularly, so what we have here, this is 2. That's where 2 is. So this is 2.0 centimeters, right? And what is this? This is 2.1. So we know that the true length of this object is between 2.0 and 2.1. So when we are measuring using a ruler, we have to write it as 2.0 or 2.1. Both of these are correct, but if you write 2, just 2, it becomes wrong. It has to be 0.0 if it's just 2, right? Because of the accuracy. The accuracy is 0.1. Well, now that we couldn't measure the distance or the length that we couldn't measure, I'm going to show it by this. So this is the the length, right, that we couldn't measure using a what? Using a ruler. So we are now going to be able to measure it if we use a what? A vernier caliper. So on a vernier caliper, there is a main scale and there is a vernier scale. I want you to imagine that where the zero of a vernier scale is, that's where the object ends, right? Let me use a different color for this one. So the object ends here, all the way from the zero of the main scale up to zero of the vernier scale. So when you take your reading, imagine that the object flashes with the zero. So normally we don't show it. Here I've shown it so that we see what we are talking about. Normally you will find a scale like this, and what you have to imagine, your object is flashing here. Whatever you are measuring is flashing here, right? So if it's flashing here, that means this is where you are supposed to take your reading. And notice, if you are just using the main scale, the main scale reading is just 2.0. Is 2.0. It's 2. That's 2, right? If it was only the main scale. So the vernier scale will put a point something. Yes. So let's see how we do it. So here it is. So when you're taking a reading from the vernier caliper, the reading, you take the main scale reading first, then you add the vernier scale reading multiplied by the what? The accuracy, right? So how do we do that? Reading is equal to, what is the main scale reading? The main scale, remember what I said? I said the object comes up to here, so it flashes with the zero of the vernier scale. So because the object ends here, I'm going to take the value which comes just before the zero. This is zero. We are talking about this zero. This zero, right? On the vernier scale, the value which comes just before the zero on the main scale, on the vernier scale, but the value has to be on the main scale. So main scale first, then vernier scale. So that value is 2. It could be, the value could also be coinciding with 0. If it's coinciding with 0, we take that value, but for this one, it's just before the 0. So it's 2. Remember, it can't just be 2. It has to be 2.0 centimeters. Why? Because the accuracy is 0.1 centimeters. This is the smallest division. How do I know that? Because when I count from 2 to 3, this is how I count: 2.1, 0.2, 0.3, 0.4, 0.5. I'm increasing by 0.1 every time. 0.1 is the smallest division, which is the accuracy. Well, after taking this, I'll take the vernier scale reading. The vernier scale reading, it's a value on the vernier scale which coincides with a mark on the main scale. Remember, you can't take the main scale reading twice. We have already taken 2.0, right? Now we have to take some value here. 0 does not coincide, 1 does not coincide, 2 does not coincide, 3 does not coincide, 4 does not coincide, 5 coincide. So go coincide with that value e lebaganeng le some mark. So 5 ke yone hele lebaganeng le a mark from the main scale again. So 5 ke yone hele lebaganeng. That's okay. So that's 5 times 0.1 centimeter, which is the accuracy. So get 2.0 centimeters plus 0.05 centimeters. So the final reading will be 2.05 centimeters. So this is the the final answer. Right? That's it.